So we'll start directly by going through the agenda of today's topic. Essentially, what we'll be trying to cover here in a 30-minute webinar is mostly an overview of capabilities provided by MSC Nastran. Some of you may already have access or being experienced with MSC Nastran a little bit. This is intended to be an eye-opener on what you can do with those recent addition of capabilities in MSC Nastran. And for those of you who are used to the legacy MSC Nastran, certainly question yourself about what MSC could bring to you today and improve your ability to perform assembly modeling faster, but also reap some benefits on the physical meaning and representativeness of the analysis you're performing with your assemblies. So the first topic we'll cover is how to assemble models efficiently using glued contact. The reason why we want to cover this here today is that people that are familiar with contact technology have a certain mindset about using contact, touching contact or glued contact. And this here is an attempt to show more examples so that you can relate to and possibly integrate into your simulation processes to obviously obtain some benefits with it. The next thing we'll cover is to integrate realistic contact. Obviously, if you have the realistic contact in your solution, you will certainly benefit of having a better load path and a more physically representative structure. We'll talk quickly about MSC Nastran connector technology. For those who are not familiar with this technology, this is very useful when you have thousands of connectors and you'd like to obviously not spend months and weeks trying to model these, but to use leverage the technology of MSC Nastran with respect to connectors to make it very efficient. We'll take a look at the latest edition of the bolt element in MSC Nastran 2011 and 2010 also. This is certainly to improve and make it easier to fasten models and do bolt preload studies and also apply external loads afterwards. And we'll do a quick overview of SimXpert and talk about how to manage models and model assemblies. SimXpert has a component that's called Enterprise Model Browser, and we'll try to highlight the value in light of performing and maintaining files when you work with assembly level type of models. And we'll have a little Q&A sessions towards the end. And certainly glued contact here is very useful to take parts and glue them together. The benefit could come from either assembly level or also performing global-local studies. So rather than having a global-local model where you take a very coarse model and you take boundary nodes and recover loads for each subcases and apply them either using fields or any other means, in working on a local model to recover localized stresses or load transfer and that kind of studies. Working with integrated global-local is certainly very interesting because once you set up the model, then you have a continuous boundary, and once that is done, if you have hundreds of load cases, then you can recover localized stresses directly. So that certainly is a benefit. If you work in a higher level system assembly type mode, then obviously if you receive models that are coming from a detailed stress organization, then obviously integrating them into your loads model will certainly be faster if you use loop technology, and I have a few examples downstream that will cover that as well. So here's an example of a curved panel that is very akin to aerospace needs, but also applies to any type of industries, where if you want to obviously integrate a localized detail without having to perform large mesh transition areas that will skew your stiffness, integrating for refined mesh areas with glued contact is very effective, it's fast, and it certainly is a benefit on the post-processing end as shown here. Also, the value of glued contact comes into play when you perform glued contact with the basic Nastran solutions, Solution 101, and also Solution 103, 105, buckling, and all the dynamics. So here, the bottom right-hand side PC board chip is glued to the surface, so you can glue 2D and 3D structures together very efficiently, and then obviously you can perform dynamics. So glued contact is only established right at step 0 of any run, so that is now enabled in basic linear solutions as well. Here's a perfect example of replacing a coarse rib into a coarse model by a refined rib. So if there's a geometry change by the team that is performing work on the rib, you can directly integrate it into the course model and potentially make an assessment early in the design on the effect of changing the geometry at the rib level, and also performing localized studies as well. This is an example showing where we have glued the 3D chip to its leads and the leads to the PC board, which is actually a shell component here. And because glued contact is established right at the start, then you can push this into frequency response and perform modal analysis, or random in this case. Another benefit of glued contact is this is a world where I come from, working with thick honeycomb structures and composites. The typical assemblies required using legacy Nastran practices to extend the geometry, modify it, and end up with a congruent mesh assembly. And that posed a few problems. First challenge is, if the geometry is complicated, then you need to extend and match everything and get congruency in your nodes. Whereas if you just leave with the mid-surfaces of the honeycomb and you stitch them together using glued contact, then you save your time some geometry handling and pre-processing. And obviously at the corners, you have the physical representation of the actual stiffness. So that provides better results with less work. A nice case study here that will take a look physically with the model is this example where, if I position myself as the integrator of the aircraft, and I've been working with the loads model mostly, which is the course portion, and then somebody late in the design comes up with the mid-fuselage section and says, we have increased number of ribs, and also we may have some access holes, and we want to know if these will affect the stability or the performance of the aircraft. Rather than making a reduction and integrating into the loads model, why not just take the detailed FEM and integrate it and glue it to the rest of the structure? And the result shows that the relationship between the coarse and the fine model works very well. So if I take a look quickly into SimXpert, just to illustrate what we have here, this is exactly the model we've been looking at. And we see that we have the ability to stitch these edge-to-edge glued contact shells. And we can even take care of the fact that the arc of the course model has a different edge, and it creates some little gaps there. But this can also be, and I think we have it here, it's all captured. These can be, controlled by the tolerances of the contact, and the algorithm allows us to make a very nice, smooth glued contact edge there. SimXpert also have the ability to work with automatic glue detection. So in the case that you work with parts concept, you can go and create automatic contact tables just by identifying parts automatically. And this will enable you to create a contact table where each body will glue itself to its adjoining neighbors, and then you can start tuning the parameters because the tolerance will be different depending on the mesh density jumps. Once the glued contact is established, you can actually perform a glued contact status check. Once you have the contact status check turned on, you can actually identify that you do have proper matching of the two contact bodies. So the blue will mean that actually this one is being glued to the next one very nicely, and the red one internally as well. So this is a means by which you can validate that the contact has been established at each node. Once you're satisfied with the results, and you can obviously appreciate, I'll try to do a little animation here of the tail, which is mode 7. I'll turn off the glued contact here, and then we try to make it a little animation here. So you can see that there's very good continuity right at the edge of the glued contact components. Okay, just an illustration here. If you have questions at the end, I'll be happy to answer them. Go back to our presentation. So again, SimXpert is a nice environment to perform automation, and therefore I created this little template that enables you to automatically take a run-ready model, and it solves without applying any loads and returns the contact status and display them for you automatically, and also reads in the contact NPCs that have been created by the software, those green lines here. That this is very useful to validate that your glued status is ready and accurate in terms of pre-processing just before you actually recover your results. Beyond glue contact, just a little word here that if you use our nonlinear implicit solution 400, you can actually turn on the ability to break the gluing contact. So this is very useful in terms of establishing the load path after part separates. And the separation criteria is by the equation shown here, which is a user-defined interaction curve between allowables on the normal and shear stresses. And you can play with the exponent M and N's there to make sure that you validate the criteria against with possibly test coupons or testing results. So you can tune this and then integrate into your structure so you can validate that if a component separates from another, it could be bonded, could be composite failures, then the load path will change and you can measure and appreciate if the failure is actually catastrophic or not. So I think I've covered enough of glue contact here, a few good words about glue contact. When you recover this presentation after the webinar, you can review that and come back to us with some questions if you have any. So now what we'll do is we'll move on to the or touching contact in linear and nonlinear. Touching contact is an extension of the contact, whereas the contact bodies will come in contact together. They will touch, they will not stick, but they will separate. And the nice thing about MSC Nastran, you're enabled to use this also in Solution 101, so in linear touching contact is allowed. So you can have very representative structural reactions after a certain load. So if contact bodies come and touches together, and you have a fastened assembly like a bracket and a plate, you will recover the right load path. And this is an assumption which is usually taken at the hand calculation side when you have large assemblies. Now, if you integrate this into your large assemblies and you have the right reactions, the benefit could be that for a certain bracket type and a certain number of fasteners, you could potentially recover more loads through the heel and toe effects and possibly either reduce the size of your fastener or reduce the number of fasteners that are used and considered in the application. And that will certainly help you reducing the weight of your structure. Other benefits of touching contact is the ability to do interference closure. So if you have press fit type of assemblies, you don't have to worry about making the mesh to be initially penetrated. So you can just mesh at the nominal position and type in a number that will actually satisfy this interference fit. And then you obviously can validate the interference as a starting point and then apply external loading afterwards. Here's an example where we have full 3D contact with 3D model plates and shear pin. In this case, we haven't applied preload just to illustrate the shear capability, the shear recovery of the results, and the smoothness of the stresses. So this is very easy to actually resolve in Solution 101 with MSC Nastran. And here's an example where you can actually have 2D and 3D touching together. I have a little model here I can show you quickly. Let's try to review this bracket here. So what I want to emphasize on here is the ability to actually model through 2D and 3D together. 2D and 2D will also touch, and 3D obviously goes without saying. But the value is the fact that you don't have to move your shells anywhere near the solid because the solver will actually take into considerations the distance of the offsets of the fibers. So this shell is actually 50 thousandths of an inch away from the solid, but its total thickness is 0.1 inch. So therefore, if you actually, this is a very nice feature here. If we put in the shell thicknesses, should work. We see that the total shell thickness is actually touching the solid. So once this is turned on and you solve for it, you can actually look at the results. Let's do a little fringe on the stress, and we should be able to see that there's a heel and toe effect here. So essentially what we're doing is we're prying the bracket, applying the load. We're applying a total load towards the minus Y direction, and we're actually prying and hitting the keeling effect here on the toe of that bracket to the plate. So this actually generates a very realistic loads distribution, also in the fasteners, and then you can obviously perform more advanced studies with this. That's very rewarding in terms of simulation capability. The next topic is to quickly cover MD Nastran connector technology. For those that are not familiar with it, MD Nastran offers three types of connectors: the fasteners, the weld, and the seam. The particularities of these connectors is the fact that they rely on a global geometric position of point position that are projected on shelves. So you can actually very easily tie to geometric position that can be imported in either Fastener or SimXpert as geometric locations. And if you have thousands of them, you can use the connector creation utilities in each of the applications and recreate connectors regardless of where the shell meshes have moved. So if you have a design change, if there's a slight change in position, but globally the connectors remain in the same location, you can just recreate them, thousands of them, in a matter of minutes. And that's very useful. So the fastener is more like a C-bush entry. You enter a stiffness matrix, whereas the weld and the seam are actually physically volumetric connectors. So they have a material dependency, so you can evaluate the stress into them and potentially do sizing of your weld assemblies. So again, SimXpert has very good capability of keeping the connectors in a geometric fashion rather than being tied to an element per se. So when the mesh matches or doesn't match and you want to change the mesh locations to match the pattern of the welds, it's very easy to do that. Also, this is also very highly automatable, so there's a benefit of SimXpert in this case. And again, if you have a change of geometry and change of pattern, and you keep your weld location based on geometric coordinates, then you can recreate them very, very easily. So new mesh, no problem. New fastener pattern, no problem. You can certainly expedite your assemblies like that. Now, tying the fasteners with the contact certainly is a good illustration here, where I did this single lap shear joint, and I purposely created a single row of fasteners, and these will swivel quite a lot. So if you look at the displacement pattern here that you'd expect for a typical legacy solution type, all the loads are going through the fasteners, and none is actually reacted by the two plates. Whereas if you have contact in there, and the plates are actually reacting based on their physical thickness, then turning contact on with the fasteners enables you to keep the right stiffness in your assembly. So imagine you have a complicated assemblies where you have a lot of those locations where flanges are touching with adjoining bodies. These little idiosyncrasies adds up and will certainly degrade your stiffness. Whereas now you potentially recover the right load path, and potentially also recover the right fastener loads, and if you're lucky, reduce the number of fasteners and do less hand counts without it. So this is great technology because it's easy to set up, it works very well, and it certainly is a benefit to integrate into your simulation practices. Automated fastener modeling tool. This is the one regarding the new bolt element. This is also supported by Nastran and SimXpert. And the fact is that we have, on the solver side, created a simple or simplified bolt entry. Those of you who are familiar with Mark and Bolt US for Solution 600, this one has been a little bit revamped to make it easier and more intuitive to use. So you essentially pick a rows of node at the top and the bottom interface. You still have a control node onto which you apply your MPC equations, and these are actually handled automatically by the solver internally now. You just need to create yourself a control node and apply the loads to it, and the bolt preload becomes like a child's play. It works in Solution 101 with touching contact, and also very useful to use in Solution 400 with advanced implicit nonlinear solutions to do more advanced studies on localized yielding, nonlinear material, and so on. So that works very well. Now, the last topic for today we'll quickly cover in SimXpert is the ability to manage assemblies, model assemblies. So we'll just go back to our SimXpert, create a new database. And this utility is called Enterprise Model Browser. SimXpert is actually object-oriented development, so it makes it very easy to keep track of things as you work with them. In light of that, we will read in a model. This is a little UAV aircraft. And this model is, using the model browser, you'll see here that this model is actually a main include file. So this file here If I go and browse to it, you would see that this only supports like includes of the 4 files below. So when you read in models in SimXpert as a natural way with the model browser, you retain the relationship to these subfiles. So these little files here are all individual buckets in which each of the components are maintained. So if you are working in that, in light of that today, and you import your models with any other UI, you will actually end up with a monolithic model. In this case here, if we make a modification of the mesh, we have the ability to maintain this relationship, and we can actually export Nastran and multiple. So if you work on a component and you need to resend the center fuselage to a team that is working on it as detail level, you can actually re-export this and maintain the fact that it's sitting in a different file set. Now, once you have this data structure maintained, these are all objects can be pointed to and managed using the Enterprise Model Browser. So if we go to the Enterprise Model Browser, we can create a project. In this case, we're obviously starting from scratch as an example. So this is my first version of my UAV. I can create it using build from file sets. So essentially, it will recognize the file sets loaded up in memory and create design variants and maintain them as an assembly. The benefit of working with this is the fact that from this point on, and I can continue working for months and months on this project and end up with version 38 at the end of the day, and maintain those version tracking in my local data structure. The Enterprise Model Browser enables you to connect to Sim Manager if you have that in place at your facility, and obviously keep the audit trail and so on. But in this case, as an engineer working on my own stuff, I can keep track of what I'm making as a modification on this aircraft. As an example, we will modify this part. We'll transform it by 10 units in X. So you see I've stretched the tail of the UAV here. So if I go back and refresh the model, you see that we have red check marks here. That means that this thing has been modified. So we will save that. And we'll force the auto revision. So that means that we'll create a revision 2 of that model for each of the files that have been modified. So now we have a version 2 of the Predator. And once we keep adding to it, make modifications, change properties, and so on, we can keep track without having a logbook, which is mostly useful exchanging logbooks between engineers. I've rarely seen this very successfully. But in this case, we have a few tools that are very useful. For instance, I can right mouse button and say, Tools, Model Compare. And technically, if this is working, we will be able to see the differences between version 1 and version 2. So version 1 is the red one, version 2, the latest, is the green one. The blue components are actually the original ones. And beyond this, Enterprise Model Browser has lots of good capabilities to perform type of version tracking. You can even go here and say, I'm going to create myself a folder and add results and reports to it. So you know that version 38 had this performance or this modal analysis result. You can keep tidy about it and pass this information to the next person in line so that you can continue working on your material when you're done with it and keep it tidy and always find the results that are attached to this data. So a quick illustration of what you can do with Enterprise Model Browser. One thing that is very good is, again, the ability to keep track of different versions, but also different load case configurations, results, and report, and so on. In my opinion, this is a very nice facility to get rid of the black book syndrome. So that being said, well, just a little conclusion here. Assemble models efficient using glue contact. Hopefully you've seen that we can glue stuff together, we can solve it. It makes your life much easier in terms of assembling and getting an early assessment and performance check on an assembly type model, but also perform global, local, integrated in the same model. Very useful. Integrate realistic contact, obtain realistic results, especially if components are working against one another. And getting rid of the old C-gap. If you're having problems converging with a C-gap element, this technology is much more robust and much less finicky to actually converge. The connectors enables you to connect things together. So if you're working with thousands of connectors, it's easy to modify and keep track of the design evolution of your structure. Preloading made easy. So with the new bolt element, this is enabling you to perform preloaded analysis, even in Solution 101. So this is an advanced feature of MSC Nastran. And we've seen that SimXpert offers an application enterprise model browser to keep track of models and design variants and results. In this short time span, there's been a lot of topics covered here, but I'd be happy to answer any questions if you have any.